But a question is, how are we going to make these recommendations? How are we going to guess what rating a person would give to a movie that they've never watched? Well, let's imagine for a moment that we have some set of features about each movie and each user. So for example, we know that movie V, which in this case is The Shawshank Redemption, is about some set of different genres like action and romance and drama. And so we have this vector for each of these things, which says it's 0.3 about action. It's 0.01 about romance. It's 1.5 about drama. And we have these set of things, so we know what the movie is about. And likewise, for every user, like this user U, we know which of these different genres that user likes. So for this user, we have a vector that says that for action, this user really, really, really likes action, really does not like romance, kind of likes drama, and so on. And we're going to call this first vector the movie vector, RV. We're going to call this user-specific vector LU. Okay, so let's say we know this. Then what would you do to make a prediction of a rating? Well, one thing that might make sense is to take this movie vector and this user vector and see how much they agree. If they agree a lot, then we'd guess that the person would rate that movie very highly. If they don't agree a lot, then we're going to say that it's probably very likely that they will not like that movie and give it a low rating. So we're going to estimate our rating. That's why we put this hat over it to denote that this is an estimate of how much the user U is going to like some movie V that they've never seen before. And so the way we're going to do this is just like when we're measuring similarity between two documents. We're going to take the two vectors. In that case, that might have been a vector of different topics for the document. In this case, we're talking about a vector of different topics about the movie. And so here, we're going to take these vectors, so 0.3, 0.01, 1.5, and so on, and we're going to multiply it element-wise by this vector. So this is our RV, this is our LU, and what we're going to get out is we're going to get out 0.3 times 2.5 plus 0 plus 1.5 times 0.8, and so on. And let's just say that this ends up being some number like 7.2. Just made that up. But if the user vector really disagreed with what the movie was, so let's choose another color. So this is some other user. Let's call this user LU prime. And let's say their vector said they really don't like action. They love romance. They really hate drama. And so on. Well, here, the score is going to be much lower. So we're going to get 0 plus 3 just for consistency, plus 0.01 times 3.5 plus 1.5 times 0.01 plus all these other numbers that really don't agree with one another. And maybe this would come out to be some small number like 0.8. So the point here is that when the movie vector and the user vector agree a lot, we'll get a much larger number than when they don't. So we're going to estimate a much larger rating than in the case where they disagree. And then when we think about making our recommendations, what are we going to do? Well, we'll just sort over all movies that we've predicted for that user, we'll sort by their predicted rating, and then we'll recommend those with the largest ratings. And I want to highlight one thing here. So if you remember, the rating scale was between 1 and 5, or rather 0 and 5. You could provide no stars if you really hated a movie. But the maximum score was a 5. But note here that one of our predictions is 7.2, which is clearly greater than 5. But with this type of model that we're talking about here, we're not restricted. There's nothing enforcing that we're going to stay within a score of 0 to 5. But we can still use this to make recommendations because we just look at the movies with the largest scores, even though those scores aren't necessarily representative of exactly how many stars a movie would get.